In this class we are going to learn the mode of the grouped data. Mode, in a simple way we can say that mode is the most frequently occurring distribution. If we have the observations, like for example, if the observations are 2, 7, 1, 2, 8, 7, 2, 9. See here we have the 8 observations, and in this the most frequently here 1 occurs only one time, 2 here we have 3 times, the frequency is 3, and for 7 2 times, 8 and 9 only one time. So from the given observations we can see that 2 occurs the most number of times, and from these observations mode of this observation is 2, that is the observations having the most number of frequency. And from this class we are going to learn mode of a grouped data. We will get the class interval and the frequency. From that we have to find mode. So we have the formula for mode is equal to L plus, and here F1 minus F0 divided by 2 F1 minus F0 minus F2 into H. Here the letters represent L represent the lower limit of the model class. Lower limit of the model class. Then what is a model class? Model class, and the model class means the class interval having the most number of observations, that is the highest frequency, having highest frequency is the model class. Then F1 represent the frequency of the model class, and then F0 is the frequency of the class interval preceding the model class, just before it, that is F0 is the frequency of the preceding class, preceding model class, and F2 the frequency of the succeeding model class, and then H is the width of the class interval. F and H is equal to width of the class interval. The width of the class interval means the difference between the lower and upper limits. Usually we take all the class interval having the same width. See, for example, we can take an question here. A survey conducted at 20 households in a locality by a group of students resulted in the following. That is, the frequency table is given for the number of family members in a household. That is, a survey conducted by a group of students in a locality among 20 households, and the data given is the family size, and the number of families. From this example we can find out what is the letter represents here as L, F1, F0, F2 and H. In this example, see here we have the data given is the family. If the family size is 1 to 3, number of families 7 family, and 3 to 5 8, 5 to 7 2, 7 to 9, 2, 9 to 11, 1. Here 5 class intervals are given and the frequency also. And this, here we have first the letter is lower limit of the model class. That is, here lower limit of the model class. So which is the model class? Here the model class means the class interval having the highest number of frequency. Here in this frequency we have 8 is the highest number. So 3 to 5 is the class interval, that is the model class. And we have to find the lower limit here. This is the lower limit of all the class intervals and this is the upper limit. So here 3 is the lower limit, 3. And the next one, F1, the frequency of the model class is 8. That is, this is F1, 8. And the next letter here is F0. F0 means the frequency of the class interval preceding the model class. That is this one, F0. And F2 is the frequency of the class interval succeeding the model class. F0, the frequency of the class interval preceding the model class, and F2, the frequency of the class interval succeeding the model class. So here we have F0 is equal to 7, F2 is equal to 2. Now we need H, the width of the class interval, that is, see the class interval is 1 to 3, 3 to 5, 5 to 7, 7 to 9. So the width is 2. 9 minus 7 or 11 minus 9, 5 minus 3 is 2. Now we have to substitute the values in the given formula. Mod is equal to L plus 8 plus F1 minus F0, that is 8 minus 7 divided by 2 into 8 minus 7 minus F2, that is 2 into the width of the class interval is 2. Now solve, first we have to solve inside the bracket. It is 8 plus 8 minus 7, 1 divided by 2 8s are 16 minus, adding two negative numbers we have minus 9 into 2. This 2 we can take inside. So here 8 plus 2 by 16 minus 9 is 7. 2 by 7 is, here we have a 0.286. 8.286. The answer is 8.286. So here mode of the above data is 8.286. Now let us move on to the exercise, second one. Exercise 13.2. The first question. The following table shows the ages of the patients admitted in a hospital during a year. And the data given the age in years and the number of patients. Find the mode and mean of the data given above. Compare and interpret the two measures of central tendency. That is, here we have the data, age in years and number of patients admitted in a hospital. Here 5 to 15 age group 6 patients, 15 to 25 11 patients, 25 to 35 age group 2, 21, 35 to 45 23, 45 to 55 14 and 55 to 65 5. Here the given data shows the number of patients admitted in a hospital and their age group. The class interval given are 5 to 15, 15 to 25, 25 to 35, 35 to 45, 45 to 55 and 55 to 65. And from this, first we had to find the model class. That is, the model class means the class interval having the greatest number of frequencies. See, here we have 6, 11, 21, 23, 14 and 5. Among this, the greatest number we can see is 23. So, this is the frequency of the model class. So, we can write, we know the frequency of the model class will represent by the letter F1, and we need the frequency of the preceding model class. That is, before the model class we have here 25 to 35 and we need the frequency as F0. And the frequency of the succeeding model class is F2. And we need L. L is equal to lower limit of the model class, that is 35. And the width H is equal to 25 minus 15 or 15 minus 5 is 10. Now we need mode is equal to, the formula is L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into H. Now we have L, H, F1, F0 and F2. So let's substitute. L is equal to 35 plus F1 is 23 minus F0 is 21 divided by 2 into 23. Here we are substituting the letters. 23 minus 21 minus 14 into H is 10. So 35 plus inside the bracket we have to solve. 35 plus 23 minus 21 is 2 and the 10 we can take inside. By 2 23s are 46 minus, adding two negative numbers we have 35. That is 35 plus 20 divided by 11. That is 35 plus 20 divided by 11 we have 1.8. So the answer is 36.8. The model age group is 36.8. Now the next question. Find the mode. The second one. The following data gives the information to the observed lifetime in hours of 225 electrical components. The lifetime of electrical components are given in hours and the frequency. Lifetime in hours. And frequency. Now the data given is 0 to 20, 10, 20 to 40, 35, 40 to 60, 52, 60 to 80, 61, 80 to 100, 38, 100 to 120, 29. Now here we have the lifetime of the electrical appliances in hours, that is 0 to 20 hours. We have 10, the frequency is 10, and 20 to 40, 35, and we have a mode F1 into H. Here we have the model class is the class interval having the highest frequency. Here it is 61. So that is, this is the class interval F1, this is F0 and F2, and we have the class interval 60 and 80 as the model class. So the lower limit is 60. So here let us substitute 60, and we have h is equal to 40 minus 20, that is h is equal to 20. The width of this class interval, 80 to 100 is 20, 40 to 60 is 20. Now here 60 plus we have f1, 61 minus 52 divided by 2 into 61 minus 52 minus 38, and the width is 20. Solving inside the bracket, we have 60 plus 61 minus 52, 9, and 20 we can take inside, divided by 2 into 61s are 122, minus adding 90. Solving inside the bracket, 60 plus 180 divided by 32 is equal to 60 plus, dividing 180 and 32, we have a 5.625. Dividing 180 and 32, we have 5.625. So the mode here is 65.625. In this question, the lifetime in hours is equal to 65.625 hours. Now the third one, next question. Third, here we have a student noted the number of cars passing through a spot on a road for 100 periods each of 3 minutes and summarized it in the table given below. That is, a student noted a number of cars passing through a spot on a road for 100 periods each of 3 minutes and summarized it in the given table. Find the mode of the data. That is, the number of cars and the frequency is given below. Zero to 10, 0 to 10 is 7, 10 to 20, 14, 20 to 30, 13, 30 to 40 is 12, 40 to 50, 20, 50 to 60 is 11, 60 to 70, 15, and 70 to 80, 8. Now here the data given are the number of cars are passing a spot in the road in 3 minutes. 100 periods are taken, and so we have to find the mode of the given data. So we need the L, the lower limit of the model class, that is here. The frequency is 7, 14, 13, 12, 20, 11, 15 and 8. So the greatest number here is 20. So the lower limit of the model class is 40. Here F1, F0 and F2. Here 40 to 50, the width h is equal to 10. 50 minus 40 is 10, or the width is 10. And we need L. L is the lower limit of the model class, that is 40. So we have now from the formula we have to substitute for L is equal to 40 plus F1 is 20 minus 12 divided by 2 into 20 minus 12 minus 11. Then into h is 10, the width of the class interval. Now solving, we have 40 plus 20 minus 10, 12 is 8 into 10, this 10 will go inside. 2 20s are 40 minus adding these two we have 23. 40 plus 80 divided by 17. So we have 80 divided by 17 is equal to 4.71. That is 40 plus 4.71. So the mode is equal to 44.71. Is the answer for this number. Now the fourth question. The next question, the following data gives the distribution of total monthly household expenditure of 200 families of a village. Find the model monthly expenditure of the families. Here see the question. Expenditure in rupees. Number of families. Here we have the class interval 1000, 1500. to 2000. 2000 to 2500, 2500 to 3000, 3000 to 3500, 3500 to 4000, 4000 to 4500, 4500 to 5000. The given data shows the monthly household expenditure in a village, and we have the number of families 24, 40, 33, 25, 30, 22, 16 and 7. From the given data, we have to first find out the model class, that is the class interval having the highest frequency. Here we know 40 the highest frequency, so we have the model class here, and this one F1, and the preceding class interval frequency is F0 and this F2. Now we have F1, F0, F2. The lower limit of the model class is 1500, and the width 1500 minus 1000 is h is equal to 500. The width of the class interval is 500. So substituting in the formula, we have L is equal to 1500 plus F1 is 40 minus 24 divided by 2 into 40 minus 24 minus 33. H is 500. Here 1500 plus 40 minus 24 is 16, and into 500 we can take this inside, divided by 80. 2 40s are 80 minus, adding these to 57. So here 1500 plus 16 5s are 80 and 2 zeros, divided by 80 minus 57 is 23. Now 8000 divided by 23 we have here. It is 347. 1500 plus 347.83. So adding, we have a 1883. See here, model class interval is this one, and see we have the model expenditure is 1847.83. Now the next one, we know how to find the model class, the class interval having the highest frequency. Take the next question. The next question is, the following distribution gives the state-wise teacher-student ratio in higher secondary schools of India, and find the mode of the data. that is the number of students per teacher. The following distribution gives the teacher-student ratio in higher secondary. The number of students per teacher. And the second one, number of states. Or union territories. Here the class interval given are 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50 and 50 to 55. Per teacher, the number of students per teacher is given in this class interval and the number of states. In the 15 to 20 class interval, 3 states, 20 to 25, 8, 25 to 30 is 9, the next one 10, then we have a 3, then the next two have 0 and 2. Here, now for this question also we had to find the model class first, that the class interval having the highest frequency. Here we know the highest frequency is 10. So the model class here is L is the lower limit 30, F1, F0 and F2, and we need the width. H is equal to 20 minus 15 is 5. So from the formula we have 30 plus 10 minus 9 divided by 2 into 10 minus 9 minus 3 multiplied by 5. 30 plus 1 into 5 divided by 20 minus 12, that is 30 plus 5 divided by 8. Here we have 30 plus 0.625 is equal to 30.625. Here the data shows per teacher 30.625 students. Now the next one, in the next question we have, the distribution shows the number of runs scored by some top batsmen of the world in one-day international cricket matches. So the runs scored and the number of batsmen. The runs scored are 3000 to 4000. $4,000 to 5,000. 5,000 to 6,000, 6,000 to 7,000, 7,000 to 8,000, 8,000 to 9,000, 9,000 to 10,000, and 10,000 to 11,000. Now here the number of batsmen scored in this class interval are 4, 18, 9, 7, 6, 3, 1, 1. Here the runs scored by the batsman are given and we have to find the mode of the given data. For this, we need the highest frequency 18 and L. For this one, F1 and F0, F2. Now H is equal to 1000. That is 4000 minus 3000 is 1000. So solving for mode, L is equal to 4000 plus F1 is 18 minus 4 divided by 2 into 18 minus 4 minus 9 multiplied by 1000. That is 4000 plus 14 divided by 36 minus 13 into 1000. That is 4000 plus 14,000 divided by 23. So here 4000 plus dividing we will get 608.69. So the average model score of the batsmen are 4608.69. So in these questions, for the mode, first we have to find the class interval of the highest frequency and take the lower limit. And before we have F0 and after that F1. First we have to mark F1, model class lower limit, model class is highest frequency class interval, and F1, F0, F2, that is F0, F1, F2 in order, and H is the difference between the class intervals. And directly substituting in this formula, we have the answer 4608.69.